Have you ever randomly looked up at the sky and realized that it's one of those nights when the stars appear brighter? So bright that you can even recognize some constellations? Whenever that happens to me, I think of the words of Esperanza Carrasco, saying that astronomy has taught us that as far as we know, we're the only form of life aware of its place in the universe. The Mayas, centuries ago, looked up at the same sky we do today, coming up with their own understanding about their place in the universe. Perhaps by studying the Mayan perspective, we can gain a deeper appreciation for our own place in it. Mayas charted the heavens, tracking the movements of planets, stars, and the moon. And with their sophisticated calendar system, they were able to understand the cyclical movements of their sky and even predict celestial events. These weren't just abstract observations. Their cities were built to line up perfectly with the cycles of their sky, serving as astronomical tools to keep looking up. They align pyramids with the rising and setting of celestial bodies, and their architecture even mirrors some constellations. Because for the Mayas, celestial bodies were more than just objects in outer space. They were a communication system with their gods. Reading the sun, the stars, and the moon allow them to know their deity's will and actions. They believed astronomy represented the order of the universe, so every twinkle in the sky was actually a symbol for them and for their God's place within that sky. And that's where their astronomical storytelling comes from. Being deeply connected with their observations, they turned into stories about their understanding of their place in the universe. Now, we do a similar thing, but we have sophisticated scientific tools at our disposal to do so. One of them being the Drake equation. The Drake equation was developed by the astrophysicist Frank Drake in 1961, and it is a scientific attempt of estimating the number of intelligent and communicating civilizations in our Milky Way galaxy. Each of its factors represents one of the chances that make up the chance that aliens exist. And these are the number of stars made in the Milky Way galaxy in 1 year, the portion of those stars that have planets, the portion of those planets where life can exist, the portion of those planets where life does exist, the portion of those planets where intelligent life exists, the portion of that intelligent life who develops technology that can communicate outside of their planet, and lastly, the number of years an intelligent and communicating civilization may last. Now, I know that was a lot. It's okay if you couldn't quite grasp it all. Basically, these are just a bunch of variables that make up the chance that aliens exist. And while we don't know each exact value, discoveries in astronomy helps us refine them. There's an article by the Arizona State University that describes how this equation can be solved. Let's look at it together. They began by estimating that our galaxy forms 10 new stars annually. Of those stars, they believe 100% will have planets. And those planets, hypothesizing that life, 25% of them will harbor life, and if life can exist, it will, 100% of the planets that could have life will have life. Then they hypothesize that only 1% of this life will become intelligent, and only half of this 1% will be able to create technology that communicates outside of their planet. Lastly, they believe that these civilizations will exist for 1,000,000 years. So, if you were to multiply all of these values, it would equal 12,500 intelligent and communicating civilizations in our Milky Way galaxy. But let's think of how we got that number. The first value is actually an estimate because our Milky Way galaxy produces 6 to 7 stars per year, not 10 as suggested. The second value is hard to know for sure. We're only believing that all of them have planets, but the portion, like the exact portion, would be less than 100. The third value is also hard to know for sure. Thanks to our advanced technologies, we now know that 25% of stars have planets in habitable zones, but we don't know the exact portion of which planets are in habitable zones and which are not. And if you look at the parentheses, we see that most of them are estimates because the Drake equation is currently unsolvable. It is just another attempt of estimating that same question the Maya might have pondered. Are we alone? And what's our place in the universe? Interestingly, recent studies have taken the Drake equation a step further. Professor Adam Frank of astronomy and physics at the University of Rochester has found a way to minimize the equation to three uncertainties. First, how many stars have planets and habitable zones, which we know thanks to ongoing research like the findings of NASA's Kepler satellite. Second, how often life might evolve and lead to intelligent beings, which we know because Professor Frank, along with Rudolf Sullivan, have found a way to calculate how unlikely advanced life must be if there has never been another example in the universe. And third, how long the civilizations may exist for before becoming extinct. This last bit of information puts the whole equation together, but we don't know it. So Professor Frank and Sullivan have recognized the difficulties in including this last variable and created a simplified version without it. It focuses more on the number of civilizations that are intelligent and communicating, but that have existed over the history of the observable universe rather than the ones that exist right now in our galaxy. What I'm trying to get at is that the Drake equation keeps getting revised and reinvented, and it highlights one key point: human desire to understand life in the universe. Fueled by the same curiosity, we, like the Maya, continue to seek answers about our place in the universe. And we know we got 12,500 intelligent civilizations. That's a lot. But the Fermi paradox asks, if there's so many, why haven't we found any yet? Perhaps intelligent life is extremely rare, or civilizations go extinct before reaching communication capabilities. It could even be that our systems are not complex enough to understand their signals yet. There could also be limitations in our research methods, such as the findings and variables like what intelligent life is. But these unanswered questions only fuel our curiosity further, which is why the Fermi paradox, despite its negativity, is an important motivator not only in the search for ET, but in the search for life meaning. Currently, organizations like the Search for Extraterrestrial Intelligence Institute are actively looking for signals, and upcoming telescopes like the ELT will allow us to study exoplanets with greater detail. With every discovery, we get closer to answering the fundamental question: are we alone? The vast Guatemalan sky, once a Mayan storybook, asks the same questions that sparked their wonder. And while we might not have all the answers yet, the Drake equation and the Fermi paradox highlight our ongoing scientific work put into understanding life beyond Earth. Perhaps the answer to the Fermi paradox lies not just in the silence of space, but in the depths of our own curiosity. The human spirit, like the stars themselves, is driven by the need for exploration, understanding, and connection. And so, we keep looking up because, as American astronomer and planetary scientist Carl Sagan once said, somewhere, something incredible is waiting to be known. Thank you.